Okay, hello my friends and everybody, and welcome back to Making an Engine, and of course, Making Snake. I might actually change the title of this to Making Snake, because that is pretty much what we're doing now. We're editing the engine slowly, or a little bit as we're going on, but for the most part, we're done with the engine. So, we're now going to be working on Snake. I did lose an episode. Basically, I didn't do a lot. I made a rotation function for the snake, and I made the snake constantly moving. I did an update function, basically, is all I've done. But I've also added a rotation thing, so I can, here where I'm drawing, if you see me do this, this is going to look really weird. I haven't done this since I put this in, actually. But this should be quite good. Oh no, wait. I clicked on that, didn't I? There we go. Now the snake's head's just spinning on top. I was trying to work out how to do the anchor point, but I couldn't work that one out, so I'm going to have to have a look into that one. To change the anchor point to be the middle instead, because at the minute, if I'm trying to... I'm trying to anchor, see, it's like rotating around these four squares, so I'm going to have to work out a way to move it and stuff like that. But for now, I've not meant to have done that. One more thing I do have to do is I need a new sprite in this, which is going to be this dot corner, and it is sprite number 3. And then over in here, just add another one called corner. So yeah, what we're going to be doing today is hopefully locking it onto the... What am I locking it onto? Locking it onto a grid, and then making it so it travels around that grid. And that's why we need the corner, because if I do this and do corner.draw and also copy this and put corner in that as well, and just set the position to another 32 on top of that, so it makes 96. You'll now see what corner is, because obviously the snake is going to have to bend around corners when we change direction. That's what corner looks like. It's at a weird angle, I know, but don't worry about that, that's not important. Or is it? We could just do this just to make sure that it's all rotated in the right way and everything's done properly, I think. So there we go, so now we've got corner that's rotated properly. So there's the corner piece that will be used. So what we're going to do is when we actually make our snake, we are going to pass it a X and a Y. So what I'm going to do here is make an int and call it level X and set that as 20, and make a new one, call it level Y, and set that to 20. Then we'll pass this level X and level Y. That was dreadful. And then we'll copy that and paste it in level here. So now we're passing level X and level Y. What are you moaning about? Oh, because the constructors don't match. That's fine. I'm about to change that now. LX in LY. There's that, and then in here in LX in LY. Okay, so now we have that. We are going to make or we're going to store, actually, we need to store it. A vector of, what do we need to store? We need to store, for each point, we need to store a direction, and we need to store a integer based on, right, what we'll do is we'll do an int, and call this piece. That makes sense, believe me. We'll also do an int, call it direction. I should... what I'm going to do is actually in main.h define a... What am I defining? It's gone from my head. I define one in sprite, not sprite. Level? Don't define it in level. Sprite sheet. Yeah, a struct. That's what I want to do. I completely forgotten the word. I want to define a struct and call it level info. And literally it's just going to store an integer that is the sprite or object, whatever it's going to be, and an integer which is going to be direction. When I can type direction, there we go. Okay, and so what's this? Integral enum type. switch direction. What is going on? Oh, because I've done that. So in main now, we're going to delete this that we've just created, and instead we're going to, no we're not, we're going to create an integer array and call it level. And we will make it 20 and 20. Now something I do need to do just quickly. Let me just put them variables back in, and then do this. Also, instead of level, I'm going to have to call it level grid. This will make sense in a moment, I hope. One thing I do want to do is just see out size of level info. So basically, a new level info, I want to see how big it is. It should, if I'm correct, and it's very rare that I'm correct, but if I am, it should have a size of 8. And I think I got it. Yeah, it's 8. Awesome. So, what this means is level X will equal size of level grid. Fuck, that's going to be huge. Because level grid itself, oh, fucking hell, is going to be 20 times 20 times 8. So it's going to be 400 times 8, which is 3200, 3200. Divide that by 20 times 8, I think. What's wrong with you? Size of level grid divided by 20 times 8. Yeah, I think that's right. And then this one should be size of... Ooh, wrong button. Level grid 0 divided by 8. Let's just check that they're right by, of course, printing them into the console. Level Y. And a nice little end line on the end, because I do like to make sure things are nice and clean. And hopefully that should show 8 and 8, 20 and 20. It does! Awesome. So now our level grid is drawing correctly. In level grid. So now we have the level grid. When we pass... when we pass snake update, we are going to also send it level grid. Too many arguments in call, right? In snake.h, also in here, in update, we want to get an integer called grid. Can I? I can't do that, surely. No, it has to be a pointer. There we go, I think. Hopefully that works. An integer pointer called grid. Now, do I need to... What are you writing about? Level info. Oh, of course, it's not... Oh, fuck. I'm going to have to pull level info for another way, which will probably be through... There. Maybe. I think that works. This should work. And then change the integer pointer to a level info pointer. And same here. Now that should be fine. Yep. Argument of type level info 20 is incompatible with argument type. Fuck. 0 0. And let's then pass it level X and level Y. Can it correct this for me? I'm just going to type it. So we want to pointer to the first position, and then level in level X and in level Y. that into here, like so. And now everything should be golden. Oh fuck, because it don't need... No, wait, because it needs the address of that. Because it then... The following... Yeah, the following addresses coincide. Awesome. So now we're passing Snake the actual grid. So now when we are doing this, what we need to do is we need to go through the entire snake and update it. So what we do need to do is define snake head as 0 and body, ooh, let's do this in caps map. Snake body, snake towel, snake corner as 1, 2, and 3. So we are now going to get rid of this because we are no longer moving the snake in that way. We are going to instead... Oh, what are we going to do instead? I need to work this out. So instead, what we're going to do is... Do we want a for loop? Let's go for a for loop. Why not? In I equals 0, I is less than level x, I plus plus. For in j equals 0, j is less than level y, j plus plus. Standard for loop to go for our double array. Let's get a new level info, call it info, and set that to equal grid I j. I think that should work really, no? Aye, you little fucker. Level info, right? No, no, not that. Pointer to a pointer. I think. Yeah, that should work, right? We want a pointer to a pointer. Awesome. If if info dot sprite equals, oh no wait, we can do this as a switch block, I think. So basically what we need to do is we need to update the head. That's what we need to do. So the first thing we need to do, or should we store the head position? The X and the Y that we've got will store the head's grid position. Let's comment this out for a minute. So the snake's head position will be its X and Y. So we know we need to start there. And what we're going to do is we're going to update it with a new direction. The direction that will be on the head, or the direct... Oh my god, right, so the direction that's on the current block, so this block that we're standing on, so we're searching through this entire array, this direction on this spot will be the direction that it moved to get here. So if we're on a corner piece, we've come from the top and we're now on the corner piece, and we come in from the right hand side, the direction for the corner piece will be up. No, it won't, it will be left. It will be left because left is the direction that we moved to get here. We moved from the position on to our right, so we moved from that one, we moved left to get to the corner. The one above was up because we moved up to get to that point. That's how we're going to arrange this. So the first thing we need to do is get our head position and update that. So in new head, that's not how you spell new head pos x equals, this is where we needed the direction thing. Let me just roll back. There we go, we're going to need this. We do need to make this just a pointer again. So we're going to switch direction, and we are actually, rather than doing this, we're just going to minus. Though we'll leave it as this speed. We'll just actually have to change this for the grid references instead. So we need to send this tile X and tile Y as well at some point, but I think we might be able to get that just through head and tail, just through the head sprite. So we've updated, we've got the new X and Y. Oh, let's store old X and Y. Old X equals this X, old Y equals this Y. That just makes it easier for me to calculate next time. Not calculate, get the head position. So we need to do is test. No, because we're not going to do collisions. Do collisions in the next video probably. So grid this X, this Y, dot sprite equals snake head, and direction equals this direction. Right, so now we've just updated where the snake head is. We've just moved this, we've just added this snake head position, because we'll go through this when we're drawing in a minute. Next thing we're going to do, and this is going to, so we've updated the head position. Next thing we're going to do is for in I equals 0, I is less than this snake length. As I said, we will make that in a minute. For now, it's just an integer. That's all it is, just for the length of this array. The total snake length. What we're going to do is start at our old X and our old Y. And ooh, why is this on a tab? It shouldn't be. In here, we are going to make an integer called current X, current Y, and current D, which stands for direction. So, what we're going to do next is copy this. This is our code, obviously, to update a position. So, rather than using this X and this Y, we're going to use current X and current Y. Like so. I know that says current X, don't worry. And also what we do need to do is work out where it come from, and we do this using our same direction code we had a minute ago. So at the minute we're now starting, so we've done the head, we've dealt with the head's moved to where it needs to. Next we're going to focus on what is currently the head, and that should now be a body. For now we're just going to make this body. We'll write a bit of code in a minute to work out what it's going to be. We're just going to make all of this body. And we are going to update current X and current Y. No, we shouldn't. First thing we are going to do here is move this from here up to here. Current X is going to equal this X. Current Y is going to equal this Y. That just makes it a bit easier. Current D is going to stay as that. Oh, that needs an equals. Current D stays current D for now. So, current X, current Y. So this is going to choose the head position, and we're going to make it a snake body. And the direction we're going to give it is going to... The direction doesn't need to change, because it's the direction that's being good. It only needs to change when the head gets there, and the head tells it what position it came from. Next thing we are going to do is switch using the grid current X, current Y as direction. using this code. What we're going to do here is do, I need to just copy that, current Y like that, and current X like that. No, but that is wrong, because this will move us in the direction that the direction's saying. What we actually want to do is move in the opposite direction. So all this means is making every minus a plus and every plus a minus.